All right. Good morning, which it is right now. Actually, I guess it's good afternoon. Hey, 2009 number six. First thing is recognizing what it is you've got here. The derivative of function f is defined by this guy right here. Oops, if I can underline there. I'll change colors. Um, all right, okay. So this is f prime, this graph right here. It's given by g of x from -4 to 0, and this funky function from 0 to out to 4 right here. And it says f prime is continuous, shown as the figure, has x-intercepts at -2, and this point right here is 3 log of 5/3. G from -4 to 0 is a semicircle, and f of 0 is 5. So this is f prime of 0, but f of 0 is 5, so keep that in mind. We might need that later. Chances are we will. So A, -4 to 4, find all values at which f has a point of inflection. So a little bit of review real quick. F has a point of inflection. That means two things, or you can view it two ways. That means f double prime changes from positive to negative, or negative to positive. That's one way to figure that out. The problem is I really don't know what f double prime looks like readily. Or the other thing is I know that f prime changes from increasing to decreasing, or decreasing to increasing. Okay, so that's what it means to be a point of inflection. It means f double prime changes from positive to negative, or f prime goes from increasing to decreasing. Because remember, when f prime changes from increasing to decreasing, oops, nice little not curve, smooth curve, but anyway, that's my point of inflection. F prime is increasing here in the first part, and then it's decreasing here. That's my point of inflection. So looking at this graph, since this is a graph of f prime, this is the definition I want to use. Where is f prime changing from increasing to decreasing, or decreasing to increasing? Well, f prime is decreasing to -2, then it's increasing, and then it's increasing to 0, and then decreasing. So since f prime is decreasing, oops, let me rewrite it this way. Since f prime changes from decreasing to increasing at x equals -2, x equals -2 is a point of inflection. Since f prime changes from increasing to decreasing at x equals 0, x equals 0 is a point of inflection. Okay, so there's A. B. Find f of -4 and f of 4. Okay, initially this looks like a very difficult question because we don't know anything about f. Since we know what this is, or since we know something about f prime. Sorry, I had to pause. That was cool. Son just called and asked if I wanted something from In-N-Out, so I had to take that order. Anyway, f of -4. Since we know something about f prime, and I know something about -4, this kind of needs to tip you off to something about the fundamental theorem of calculus where I know that the integral from -4 to 0 of f prime of x is f of -4 minus f of 0. That's it, and again, it's one of those things where it might not seem completely natural to look at right now, but at the same time, we're looking to see, do you see the relationship between the derivative and the function, and can you make the connection that it is the fundamental theorem of calculus that makes that relationship? So the question is, do I know what f of 0 is? And the answer is yes, it's 5. Do you know what the area under this curve is from -4 to 0? And since this is a semicircle, oops, can we figure out that area? Yes, so therefore I should be able to figure that out. So let's do it. F of -4 would be f of 0, if I add it to the other side, plus the integral from -4 to 0, f prime of x, which is f of 0 is 5, plus the integral from -4 to 0. Well, if you look up here at the graph, oops, the whole area is 4 times 2 is 8, minus the area inside the half a circle, and half the circle is pi r squared over 2. So to be pi times the radius 2 squared over 2, which is going to be 5 plus 8 minus, that's 4 pi over 2 minus 2 pi. So that's going to give us 8 plus 5 is 13 minus 2 pi. Okay, so there's B, or f of 4. And I will go ahead and continue on up and look at f of 4. F of 4 is going to be something similar. I'm going to lose my picture here. F of 4 then is going to be the integral from 0 to 4 f prime of x is f of 4 minus f of 0. So f of 4 is f of 0 plus the integral from 0 to 4 of f prime of x. And f of 0 again is 5 plus the integral from 0 to 4 of f prime of x. And the question is, do I know that? Well, from 0 to 4, that's going to be this integral. I know that function. So can I calculate the integral of that? Let me see if I can make this a little bit smaller so I can catch it all in there. So that's going to be the integral from 0 to 4 of 5 e to the negative x over 3 minus 3 dx. And again, since it's non-calculator, I've got to go ahead and do it. So it's 5 plus, I'm going to let u equal -1/3 x. So du is -1/3 dx. Put in a -1/3. Take out a -3. So to be -3 times the integral of 5 e to the u minus 3 du. Does that make sense? And I plug in 0. This is going to go from 0, plug in a 4 to -4/3. Okay, so then this becomes 5 minus 3, and I take the integral of this. That's going to be 5 e to the u minus 3u from 0 to -4/3. A little bit messy, but that's okay. So then I got 5 minus 3 times 5 e to the -4/3 minus, plug in 4/3, I get plus 4 minus 5 e to the 0 minus 3 times 0, which becomes 5 minus 3, 5 e to the -4/3 plus 4 minus 5. And we'll just do one more little simplification, I think. 5 minus, this is going to be 3 times 5 e to the negative 4 thirds minus 1. And we can go ahead and leave it at that. I will simplify it some more so you can check your answer in case you did. But this would be negative 15 e to the 4 thirds plus 3, so it'd be 8 minus 15 e to the negative 4 thirds. Okay, then we got to come back up for part C, and I'll go ahead and put that over here. Part C says for negative 4 to 4, find the values which f has an absolute maximum. Well, we have to look at the critical points. Well, the critical points are when f prime is 0 or undefined, and f prime is 0 when x equals negative 2 or 3 natural log of 5 thirds. Well, I can say this, for x less than negative 2, f prime is positive, right? For negative 2 less than x less than 3 natural log of 5 thirds, f prime is positive. And for x greater than 3 natural log of 5 thirds, f prime is negative. I'm basically making a sign chart here without doing that. So I recognize the fact that, and again, this is not my justification, this is just me thinking of it. In other words, I did this. Let me do it so you can see it this way. 3 natural log of 5 thirds. I did f prime is positive, f prime is positive, f prime is negative. So since this is the justification part, since f prime changes from positive to negative at x equals 3 natural log of 5 thirds, 3 natural log 5 thirds is, and that's, since that's the only one, is the absolute maximum. Okay, done deal.